here's another problem that we're going to use the combination formula to figure out the probability of a certain event happening. And for this problem, a box contains 15 transistors, 5 of which are defective. If 5 are selected at random, find the probability that all are defective. And for part B, find the probability that none are defective. This particular problem is not that difficult of a problem, except that the worst part about it is trying to reduce the fraction that you get on part B. So we'll work through it, and I'll talk about the reducing when I get to the end of the problem. So let's see, the box contains 15 transistors, 5 of which are defective. 5 transistors are selected at random. Find the probability that part A, all are defective, part B, none are defective. Now, when I typed this up, I left this little space here between the problem and part A, because in this little space, I'm going to first find the sample space. The sample space will be needed for both part A and part B. So let's go ahead and find the number of items in the sample space. There are 15 transistors, so for the sample space I'll count all 15, and combination 5, we're selecting 5 and not in any particular order, so it's 15 combination 5. In my calculator, I'll put in 15, select NCR, type in 5, press equals, and I get for the sample space 3,003. There are 3,003 ways to select 5 transistors from a group of 15. Now for part A, find the probability that all are defective. So a success in this case would be that all are defective. For that, I'm reading the problem again. 5 of them are defective, and I need to select 5. So a success would be 5 combination 5. I have 5 defective. I select all 5 of the defective. The answer to that is 1. There's only one way I would select all 5 of the defective ones. Now, if you're not sure about that, you can type it in the calculator, 5 NCR 5, press equals, and I got the number 1. So the probability that all 5 are defective in this selection, probability all 5 are defective is 1 over 3003. Now for part B, we want to know the probability that none of them are defective. What I'll do is there are 15 transistors, 5 are defective, so we're going to subtract the defective ones out. To get 10 good ones. 15 minus 5 equals 10. 15 minus 5, 10 good ones. So a success in this case is going to be selecting 5 from the 10 good ones. So I'll just say 10 combination 5. Again, this is the number of successes. 10 NCR 5 is 252 successes for part B. So the probability is 252 over 3003. I have to reduce this fraction, and I'm looking at the fraction, and I'll just start at the beginning with, can I reduce by the number 2? No, because while the numerator is even, the denominator is not even. Can I reduce this fraction by 3? Now the trick to know if you can reduce by 3 is to add the digits in 252. 2 plus 5 plus 2 is 9. So I got a number there when adding the digits that reduces by 3. So 252 were reduced by 3. What about the denominator? 3 plus 0 plus 0, 3 plus 0 plus 0 plus 3 is 6, and 6 reduces by 3, so I can reduce this fraction by 3. I'll divide 252 by 3. 252 divided by 3 is 84. And then 3,003 divided by 3 is 1,001. And now I might not be done reducing. Let's look at it a little bit more. Okay, I can't reduce by 2, and if I couldn't reduce by 2 in the beginning there, I surely can't reduce by 2 again. Can I reduce by 3 again? Well, let's see, 1,001, if I add 1 plus 0 plus 0 plus 1, that's 2. So that's not, I cannot reduce that by 3 again. So 3 is not a possibility at this point. I don't need to check 4, because if I could reduce by 4, I could have reduced by 2. And we've already ruled 2 out. I cannot reduce by 5, because to reduce by 5, they would have to end in a 5 or a 0, and they do not. And, well, I could check 6, but 6 is 2 times 3. So if 2 didn't work and 3 didn't work, 6 is not going to work. 7. 7 is a prime number. Let me check and see if I can possibly reduce by 7. I'll do 84 divided by 7 is 12. Well, let's check 1,001 divided by 7, and I get 143. So I can reduce by 7. 84 divided by 7 was 12, and 1,001 divided by 7 is 143. And you can check a little bit more, but really you got 12 in the numerator. 12 is what, 3 times 4. So I've already checked those numbers for reducing, and I cannot reduce this fraction any further than that. So the answer is 12 over 143.